Okay, so probability distribution chapter, and then section is binomial probability distribution. Binomial probability distribution. So in this section, we're going to discuss about what is binomial probability distribution, and how to find mean standard deviation uh, of a binomial distribution. Okay, and so using this binomial probability distribution, how we can find out either the result is significantly low or significantly high. So these are the things we're going to discuss here. So first of all, any probability distribution, remember from previous section, probability distribution means it's a distribution of probability of an event. For any event, how many different possibilities are there and what are the probability for those possibility. That's called probability distribution, and that probability distribution is called binomial if it meets these four requirements. There are four requirements to have a binomial probability distribution. The first one is the process or procedure has a fixed number of trials. Think about tossing a coin. When we toss a coin, there are two different possibilities. Either it's a head or tail. So that's a fixed number of trial, and fixed number of outcome. But it's not about the outcome. It's about how many times we do that trial. That should be fixed as well. So you cannot just keep tossing the coin infinitely. That should be fixed number to have a binomial probability distribution. Okay. And then from one trial to another one, the trial should be independent. So think about this tossing a coin. First time it's head, and now next time, it doesn't matter what did you get at the first time, either head or tail. The next time would be it's completely independent from the first trial. So trial must be independent, and you always have two outcomes, success or failure. In our case, in this tossing a coin, there are two outcomes, head and tail. So you must have two outcome only, two categories only. Okay, so outcome, there must be two outcome. And then the probability of success remains the same in all trial. Remember, keep in mind, success means what you are looking for. For example, if you are looking for head, then that's a success for you. And if you are looking for tail, then that is tail is flipping a tail is success for you. So success depends on what you are looking for in that particular trial. So if our probability distribution meets all these four criteria, then that's called binomial probability distribution. So keep in mind, to have a binomial, there should be two outcome. To be a binomial probability distribution, always the rate of probability of success should be always constant, and there should be fixed number of trials, and from one trials to another one, the trial must be independent. So these are the four criteria a binomial to you should have, or you should look in probability distribution to make it binomial probability distribution. Okay, so some notation. Let's say S stands for success and F stands for failure in our trial, two possible outcomes. Then this is how we write: probability of success is equal to small p, probability of failure, which is complement of success, which is 1 minus p, and then N stands for number of trial. One more time, S and F, that is success and failure, these are the only two words we are using, but it depends on what do you assume to be a success for your experiment. Okay, your success could be my failure, or my failure could be your success. So it could be different thing for different experiment. So more notation here. X, we use X, a specific number of success in n trials. So X can be any whole number between 0 and n. So think about that very same example, flipping a coin, and it gives you head and tail, two different outcome. Now we're flipping let's say 10 times. Out of 10 times, let's say you want to have 3 head, so HHH out of 10 trials. So what's the probability of getting at least or 3 heads out of 10 trials? In this example, 3, the value of x is 3 and value of n is 10, and success in our case is 3 heads. Okay, P stands for probability of success in 1, so here getting a head is success, and getting a tail is failure. So probability of getting a head is equal to half. So that's P. Probability of getting a tail is Q, which is complement of probability of getting a head. So it's 1 minus half, which is again half. P of x stands for probability of getting exactly x many success among n trials. So in our case, we're looking for 3 head out of 10 trials. Okay, so you have to, again, I'm repeating this, you have to keep in mind the word success as used here is arbitrary, meaning it does not necessarily represent something good, and failure doesn't mean it's something bad. So keep in mind it depends on what experiment you are performing. Okay, when using a binomial probability distribution, always be sure that x and p are consistent, meaning x represents how many, if you go back here, x represents a specific number of success, p represents the probability of one success, x represents a specific number of success. This would be same. When we do problem from this probability distribution, we have to, we can also use this 5% guidelines rule, which we are using up to now in previous sections as well. So when we use samples, when sampling without replacement and then sample size is no more than 5% of the size of the population, treat the selection as being independent. So if your sample size is less than 5% of the population size, then we can treat that sample as an independent sample, though it's sometimes may not be independent. This is a formula we're going to use for finding probability, binomial probability distribution manually. So we just plug the value of x, n, p, and q, and that's how we find the binomial probability distribution. I'm going to use this formula and some other methods as well while calculating binomial probability from the problem, but this is the formula you can use manually, and there is a technology you can always use for finding the binomial probability. So here it says method 2, but in method 2 you might use Excel, you might use TI-8384 calculator, and the technology of your choice, you can choose anything. So I'm going to show you how to use at least Excel and TI-8384 calculator, and there is a table also. Sometime we can use table to find out the binomial probability distribution. I'm going to show you that as well. Okay, so some of the formula for finding mean, variance, and standard deviation using for the binomial distribution. If your distribution is binomial, then we can find out the mean by multiplying number of trials time probability of success for one trial. Variance can be calculated by multiplying n times p times q, and then standard deviation can be calculated by using square root of n times p times q. The same range rule of thumb, if the result is significantly low values, if the value is less than mu minus 2 sigma, which is 2 times standard deviation. It's significantly high if the value is the mean plus 2 times standard deviation, and values is not that significant between mu minus 2 sigma to mu plus 2 sigma. Okay, and any success, the probability of x number of success or more is significantly high number of success if the probability of x or more is less or equal to 0.05, which is 5%, and it's significantly low if probability of x or fewer is less or equal to 0.05. Well, we are going to use these rules while solving problem. Okay, this is one more time. If you are trying to find the probability binomial distribution using the formula, this is what we're going to use manually, but we don't have to use manual if we can use technology. So now I'm going back and then I'm going to solve some of the examples by using this definitions and formula. Okay, so let's go to our homework problem. Let's look at problem number 1 here. Let's read the question. A Gallup poll of 1,236 adults showed that 12% of the respondents believe that it is bad luck to walk under a ladder. Consider the probability that among 30 randomly selected people from 1,236 who were polled, there are at least 2 who have that belief. Given that the subjects surveyed were selected without replacement, the events are not independent. Can the probability be found by using the binomial probability distribution? Why or why not? Keep in mind, to have a binomial probability distribution, that distribution should satisfy these 4 criteria. So one is the outcome should be, number of trials should be finite, fixed number of trials. Trial must be independent, and each trial must have 2 outcomes, and then the probability of success remains same. And there is one more thing you have to keep in mind, that's called 5% guidelines rule for if your sample size is less than 5% of the population size, then that's called independent because of this sample size. So these are the things we have to keep in mind while looking at this problem. So the question is, can the probability be found by using the binomial probability formula? The answer, so look at here, there is a poll and 12% of the respondents believe that it is bad luck to walk under a ladder. So there are 2 outcomes, bad luck or good luck. Okay, that's good. One of the requirement has made. And consider the probability that among 30 randomly selected people, so there are fixed number of trials, and we want to find out what is the probability of getting 2 success out of 30. Okay, so here it meets where is that, out of 4 there are fixed number of trials, and there are two outcomes, either it's they believe or not believe, and probability of success remains same. That's what we have given here. The problem, it's a 12%, probability of success is 12%, so that's fixed. So the only thing we have to keep in mind is it independent? So because as you can see here, the trial must be independent, and that can be done by looking at here the sample size. It should be less than 5%. So in this problem it says without replacement, so we just have to keep in mind what is the sample size. The sample size is 30. So 30 out of 12, 36. Is it less than 5%? So let's look at the number here. 30 out of 12, 36, and if you divide that, it is 2%, 2.4%. It's a less than 5%, so we can assume that this is independent. So the answer is yes. Although the selection are not independent, they can be treated as being independent by applying the 5% guidelines. This is the right option we have here. Okay, so yes, so let's look at another example. Multiple choice question, each have 5 possible answer. So there is a multiple choice question and each have 5 different options, A, B, C, D, E, one of which is correct. Assume that you guess the answer to 3 such question. Okay, here is the thing. There is a multiple choice question and there are 5 options available, and one of the answer is right. So the chances of making it right is 20%. Out of 5, if 1 is right, it's 1 out of 5, which is 20%. And chances of getting it wrong is 80%, because 4 out of 5 would be wrong. So now while you answer this question, this problem also will explain us the concept of binomial probability distribution. Okay, so now look at here. Use the multiplication rule to find out what is the probability of getting out of three choices. The first one is correct, second one is wrong, and third one is correct. So what is the probability of getting correct and wrong and then correct? C denotes the correct, W denotes the wrong answer. So because they are independent of each other, so the probability of getting correct, wrong, and let me just use some blank page here. I'm going to put some blank page. Okay, so this is what we want to find out. What is the probability of getting probability of making first one correct, second one wrong, and third one correct? They are independent, so we can just use this formula. Probability of this is probability of correct, probability of wrong, and probability of correct. We know that probability of correct is 1/4 because 1/5 because there are 5 choices, right? There are 5 choices, so it's a 1/5. Okay, and probability of getting wrong is it's a 4/5, and probability of getting correct is 1/5. So if you multiply on the top, it's a 4, on the bottom 5 times 5 times 5 is 125. So probability of getting correct, wrong, and correct is 4 out of 125. 4 out of 125. That's the answer. The second question, what is the probability of getting wrong, correct, 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 wrong? By doing the very same idea, you just have to multiply, and this time it's a correct, correct. There are 2 correct, so it should be, it's a wrong is 4/5, correct is 1/5 times 1/5. So that's a probability of wrong, correct, correct. So if you multiply this, it's a 4 over 125. And similarly, the last one, it's again same. There are 2 correct and then 1 wrong, so it's a 4 out of 125. 4 out of 125. Okay, based on these results, what is the probability of getting exactly 2 correct answer when 3 guesses are made? Exactly 2 correct answer when we try to find out 2 correct answer. There are 3 possibilities. Either it could be correct, wrong, correct, or wrong, correct, correct, or correct, correct, wrong. These are the 3 options only for having 2 correct answers. So to have exactly 2 correct answers, so X is, it's a success, 2 correct answer. So what is the probability of exactly X many success? That can be found by using binomial distribution, but which is by looking this here, we're just finding what is the probability of correct, wrong, correct plus probability of wrong, correct, correct plus probability of correct, correct, wrong. So all these possible options, all these possibility, we are going to add them, which is if you add all these 4 out of 125, 4 out of 125 3 times, this gives you 12 out of 125. Look at here, it's a 12 out of 125. But if you try to calculate the very same thing using the binomial distribution formula, that can also be found by using this binomial distribution formula. What is that? So that is actually binomial distribution. Okay, here we can also calculate the very same thing by using this formula, which is how many success we want. We want 2 success, 2 correct answer out of how many. So you can see here there are 3 so if you look at here, multiple choice question is a 5 possibility based on the preceding result. What is the probability of getting 2 correct answer when 3 guesses are made? So here n is 3, x is 2, so 3 factorial over 3 minus 2 factorial times 2 factorial. If you just use this formula manually, you can also find the same answer. Let me just use this formula manually. So here probability of 2 success is equal to n factorial over n minus x factorial. X is equal to 2 here. X factorial, p to the power x, q to the power x. We know n is, there are 3 answers we are making, so 3 factorial over 3 minus 2 is 1 factorial. It's a 2 factorial. Probability of success we have given is it's a 1/5. That's the probability of success. The value of x is 2. The probability of failure is 4/5. And the value of x, let me just double check the formula here. The formula is, where is that? Yes, it's n minus x. It's 1. So that's what I made mistake here. N minus x. N minus x. It should be n minus x, which is 3 minus 2 is 1. So if you use these numbers on your calculator, which is 3 factorial means 3 times 2 times 1. 1 factorial is 1. 2 factorial is 2 times 1. 1 over 5 to the power 2. 4 over 5. So you can cancel this 2 and this 2, and if you just multiply these numbers here, 1 square is 1, 5 square is 25, so 3 times 4 is 12 over 5 square is 25 times 5 is 125. And that is the answer we got by using that manual approach, by adding all 3 of them. Okay, so that is the binomial distribution for exactly to get the exact 2 answer right. Let's look at next problem here. Assume that a procedure yields a binomial distribution, it's already given, with n equal 5 trials and then probability of success p equal 0.9. Use a binomial probability table to find the probability that the number of success x is exactly 3. So keep in mind, we can find out the binomial probability distribution by using formula like this. This is the formula, that's the manual way, you know. And there are technology, there are different ways to find out the very same information. And one of the ways is using table. So if you click here, this is the table we have given. So I'm going to tell you how to read this table. In this problem, number of trials, n is 5. So look at here, the first column gives you n. N is 5. So when n is 5, the value of x comes from the second column, which could be 0, 1, 2, 3, 4, maximum 5. So based on this problem, n is 5 and x is 3. So we go n equal 5 and x equal 3. And next thing we have to see is probability of success. In this case, it's given 0.9. So that is coming from this p. P is, you know, this value 0.01, 0.05, 0.1, 0.2, and 0.9 is somewhere here. So it's this column. So n equal 5, x equal 3, and 0.9 is where is that? This one. So the value is 0.073. So probability of getting 3 success is 0.073. 0.073. Round it to the 3 decimal place and check your answer. So that's how we can use a table given here. Okay, so but that's only one way. We can also use calculator, TI-8384, or Excel. So I'm going to also talk about how to use calculator or Excel for finding binomial distribution. So let's look at the next problem. Let's look at this one. Assume that when human resource managers are randomly selected, 41% say job applicants should follow up within 2 weeks. If 6 human resource managers are randomly selected, find the probability that at least 3 of them say job applicants should follow up within 2 weeks. So keep in mind, I'm going to use both Excel and calculator for finding this information. Okay. If you go back and check here, I use this, where is that? I use this formula. This is the binomial probability formula. You can use this formula manually, or you can also use this Excel formula. There is in Excel, you can find this formula called binom.dist that calculates the binomial distribution, and there is a meaning for these notations. So I will go over this, and also I'm going to use a calculator for finding binomial probability distribution. Okay, so let's go here. In this problem, let's start with Excel. So in this problem, first of all, let's summarize the information we have given. So assume that when human resource manager are randomly selected, 41% say job applicants should follow up within 2 weeks. If 6 human resource managers are randomly selected, find the probability that at least three of them say job applicants should follow up within 3 weeks. So we would like to find out what is the probability of success X when X is at least 3. At least 3 means X should be greater or equal to 3. So meaning out of 6, you need to find out probability of success for 3, probability success for 4, probability success for 5, probability success for 6. So you have to find each of them, and then you have to add them all. You can do that way, that's the manual way. You can use that formula, formula for probability, binomial probability distribution for each of them separately, or you can use technology. So when we use the technology, I'm going to show you there are 2 different ways to use it. One is when you go to Excel and when you hit equal sign and binomial.distribution, it asks for how many number of trials we are looking for. So let's say in this case we are looking for how many trials out of, so at least 3 of them. So we're looking for at least 3 of them job applicants should follow up within 2 weeks. So if I put 3 here, and then out of, we need to put how many number of trials we have given here. There are 6 human, out of 6 human resource, we want at least 3 of them say they follow up within 2 weeks. And then after that we have to put probability. That probability here in this case is 41%, so that means 0.41. And then right after that there are 2 ways to use this input. One is cumulative. Cumulative means this formula will calculate everything less or equal 3. So this formula will calculate the probability distribution for 0 of them said they have to follow, or 1 of them said they have to follow, or 2 of them said they have to follow, or 3 of them they have to follow. So this formula actually will calculate probability for 0 plus probability for 1 plus probability for 2 plus probability for 3. If I use 1, that is cumulative. If I just use 0, there are 2 options I can use, either 1 or 0. If you put 0, that means this formula only calculates for exactly 3 of them say 6 human, out of 6, 3 of them say they follow within 2 weeks. So that's only for the 3. If you choose 0 here, that means it's just for one individual number. If you put 1, that means that's up to from 0 to 3. But in this case, we don't want from 0 to 3. We want anything greater than 3. So we want 3, 4, 5, 6. So how we can do that is we can find the complement. So we can find out what is the probability of finding 2 of them said, at least 2 of them said, up to 2 of them said, they follow up within 2 weeks. So this cumulative formula gives us 52%. Out of 6, 2 of them would say they would follow within 2 weeks is 0.52. But we want not 2 of them. We want more than 2. We want either 3, 4, 5, and 6, which is actually complement of this value, which is complement of this value, which is 0.4764. So the complement of this, at most 2, cumulative 2 is 3, 4, 5, and 6. So that's why I subtracted this value from 1. Okay, so that's how you can answer this question. So this second answer is the probability that at least 3 of them say job applicants should follow up within 2 weeks. Okay, this formula will calculate this one, P3 plus P4 plus P5 plus P6. So let's just use this answer. If you round it to the 4 decimal place, it will be 0.4764. 0.4764. Okay, so there is another way to calculate the very same thing by using calculator, graphing, this TI-8384 calculator. For that, you have to go to, let's say, second, and then after that, this VARS tab here, which is second, is distribution. And then if you go down, there is a, there are 2 different options, Binomial Pdf and Binomial CDF. This Binomial Pdf calculates the probability for just one outcome, like 3 or 2 or 1, something like that. But Binomial CDF calculates for cumulative outcome. So in our case, you have to put how many trials you are doing out of 6. What's the probability of trial, which is what is the probability of success, which is 41%, and how many trials we want, like cumulative, because we want to find out anything greater than 3. So the way we find is anything up to 2 and minus it from 1. So that gives the complement. Okay, that gives the complement. So I am calculating this value, which is 0.523591, and I'm going to compare this thing here. Look at here. I'm calculating the very same thing the way I did for the first time. Here, this one. This is binomial distribution for at most 2 success. At most 2 success means it could be 0 success, it could be 1 success, or it could be 2 success. That is what we can find using this calculator, Binomial CDF, binomial cumulative distribution function. And now, because we want the complement of this, we want to subtract this value from 1, because a complement, the difference between the complement and its value is 1. What is the answer? Answer is here. So second, this tab, so that gives me 0.4764. So that's the same thing. So this is the formula we use if you are looking for cumulative answer. If you are looking for individual, then go to the second and distribution, and then there is a option A, which is binomial, no, option 0, which is Binomial Pdf. That's for individual. So for example, if you just want to find out P3, that's the formula you're going to use. Okay, so that's another problem. Let's look at next problem. Let's say problem 11. A survey showed that 32% of human resource professionals are at companies that rejected job candidates because of information found on their social media. If 26 human resource professionals are randomly selected, would 15 be a significantly high number to be at companies that rejected job candidates because of information found on their social media? So, 32%, the rate of success is 32%, that means 0.32. And out of 26, if 15 would say, okay, if 15 is the number of success, so we would like to find out, is that number of success significantly high or low? We need to find out that information, and that can be found by using the relation here. Look at here, what is that? For probability distribution, okay, here is the thing. For the significantly high, if probability of x or more is less or equal to 0.05, so x in this case is the x is 15. So we would like to find out what is the probability of 15 or more out of 26. So what is the probability of 15 or more out of 26? We would like to find out what is the probability of 15 or more out of 26. So we can use the same trick the way we used before. We can use the binomial probability distribution function and for up to 14 and subtract it from 1. That gives you 15 or more. or we can use the calculator. In this case I'm using Excel, but you can also use calculator. Okay, so we want to find out 1 minus binomial distribution of, so how many number of trials we are looking for? 14. That's the, we want to find out what is the probability distribution, what is the probability of success of binomial distribution up to 4 or less, and we're subtracting it from 1. That means we are trying to find the complement, which is 15 or more. So out of 26 we want 14 success with the success rate 0.32, and we want to do it cumulative. That's why I choose 1 here, and then I subtracted that value from 1 to find the 15 or more. So for the 15 or more, the probability of success is 0.006, 0.006, round to the 4 decimal place, 0.0060, which is less than 0.05. Look at here. If it's less than 0.05, then the significantly high number of success. So yes, 15 would be significantly high because the probability of 50 or more is where is that? Yes, 15 would be probability of success because the probability of 15 or more is 0.00, what is that? We need 4 decimal place, and the answer is 0.0060, which is low because it's less than 0.05, which is low. That's why it's significantly high. Okay, let's go another problem. The probability of randomly selected adult in one country being infected with a certain virus is 0.002. If you choose one adult randomly, then probability of being infected is 0.002. In test for the virus, blood samples from 29 people are combined. What is the probability that combined sample test positive for the virus? Is it unlikely for such a combined sample to test positive? Note that combined sample test positive if at least one person has the virus. The probability that the combined sample will positive is, so look at here, let's go back to this problem one more time. If you choose randomly one person, the probability of being infected is 0.002. In test for virus, blood sample from 29 people are combined. So out of 29, what is the probability that combined sample test positive for the virus? So out of 29, the combined sample test would be positive if one of them is positive. So we would like to find out this. We would like to find out, in this case, we would like to find out, this is what we would like to find. Okay, what is the probability of success for anything lesser equal 29, meaning probability of success for 1 plus probability of success for 2 plus probability of success for 3 plus ... probability of success for 29. That's what we would like to find, because if any one of them is positive, then combined test would be positive, and this is actually 1 minus probability of success, probability of failure. X equal to 0 means no success, probability of failure. So in this case you can see that what is the probability of when there is 0 success. Remember, this is not probability of failure, it's a 0 success. So but this is a binomial distribution. Okay, probability for the binomial distribution. So we can find out this by using binomial distribution. So I can go here and I can use binomial distribution. Okay, and how many number of success? We want 0, and out of 29. And what is the probability for success? Probability for success is what is that? It's 0.002. So probability of success is 0.002. And would you like to do cumulative? No, it's just 1, so it's so this is probability of 0 success out of 29 is 0.94. So sample being positive is it's complement of this value, which is 1 minus this value. So that's 0.0564. So if you round it to the 3 decimal place, it's a 0.0564. 3 decimal place, so 0.056. So that's the probability of a combined sample test will be positive. So keep in mind, combined test means at least one of them should be positive, and that can be found by using binomial distribution. Is it unlikely for such a combined sample test to be positive? So remember, anything less or equal. So is it unlikely for such combined sample test to be positive? No, it's not, because it's greater than 0.05. So the answer is, it is not unlikely such a combined sample to test positive, because the probability that the combined sample will test positive is greater than 0.05. If it's greater than 0.05, that is not unlikely. Okay, let's look at one more problem. What is that? I want to do one more problem for this formula. So let's look at one more problem. Where is that? Okay, so let's look at this problem. Assume that a different group of couples use a particular method of gender selection, and each couple gives birth to one baby. This method is designed to increase the likelihood that each baby will be a girl, but assume that the method has no effect. So the probability of girl is 0.5%. 0.5 means it's a 50%. Assume that the group consists of 45 couples. Complete part A through C. Find the mean and the standard deviation for the number of girls in couples of 45 births. So we can find out the mean for binomial distribution by using this formula, which is number of trials times the probability. So in this case, if you look at the problem here, in this case number of trial is 45, and then probability of success is so 45 times 0.5, and that's how we can get mean, which is 22.5. That's from the formula. Now the standard deviation is, if you look at the formula, it's a square root of n times p times q. So we already calculate n times p. We have to multiply this by q. So I already have, what is that? I already have n times p, and now I'm going to multiply it by so it's a n times p is a probability of success is half, probability of failure is half, and then take the square root of this number, which is power 0.5. So this is our standard deviation. So the standard deviation is 3.35. If you want to round it to the 1 decimal place, it's 3.4. Now use the range rule of thumb to find the values separating results that are significantly low or significantly high. Keep in mind, the result is significantly low if it's less than mu minus 2 sigma. So this is the value we are talking about. So calculate mu minus 2 sigma using the calculator here. So mu is 11.25 and 22.5, sorry. So mu is 22.5 minus 2 times the standard deviation is 3.4. So anything less than this value is significantly low. So that means values of 15.7 girls or fewer are significantly low. 15.7 or fewer are significantly low. And anything greater than mu plus, instead of minus you have plus. So 22.5 plus 2 times 3.4, that's 2 times standard deviation. Anything greater than 29.3 is it's significantly high. 29.3. Values of 29.3 girls or greater are significantly high. Okay, and now is the result of 38 girls out of 45 that is significantly high? Yes, anything greater than 29.3 is significantly high. So the result is significantly high because 38 girls is greater than this 29.3 girls. A result of 38 girls would suggest that the method is effective. So if by using this approach, if they have 38 girls, then that means which is greater than 29.3, then that means the method is effective. Okay, so yes,